What's the difference between a linear and an exponential function? Well, so far in algebra, we've been dealing with a lot of linear functions. And a linear function is one that has, a constant addition or subtraction. So in this case, I just started kind of listing out a pattern like we did when we did recursion. I said, well, we started at 2, and then added 3, and then added 3, and then added 3. And that's what a line does. It's a constant addition, and that constant addition is the slope. So we would typically write this as y equals 2 plus 3x, where that constant addition tells us what we're going up by every time. That's our slope. Now, we also talked about this with recursion, where we would write, that we started at 2 and we were adding 3 every time. Okay? Now, an exponential function, rather than having a constant addition, has a constant multiplication. So in this case, you'll see we started at 2 and we multiplied by 3 and multiplied by 3 and multiplied by 3. So we started at 2 and we were multiplying by 3. Sometimes you'll see that written like this with the number out front. And the way we write this as an equation is we write starting at 2 and 3 to the x power. And this really gets at what an exponent is. An exponent tells us how many times we're going to multiply. So for example, if I wrote 4 to the 5th, that would be saying I'm multiplying 4 5 times. Okay, so we're multiplying by 3 every time. We started at 2, and this tells us how many times are we multiplying by 3. Now, because this multiplication grows so fast, while a linear equation looks something, like this, an exponential equation grows very quickly, and the faster it grows, the faster it grows. It just keeps growing faster and faster all the time. Now, on the other hand, there's nothing saying we can't decrease. Okay? So in this case, a linear equation, you'll see that I'm just going down by 4 every time. So we would say, well, you started at 10, and you were simply subtracting off 4 every time. And if you remember the way we were doing that before with recursion, started at 10 and subtracted 4 every time. Now here, sometimes a little harder to see. You have to think, well, you could think, what am I dividing by? But we usually like to think about multiplying. Here we divided by 2. That's the same as multiplying by 1/2. Multiply by 1/2. Multiply by 1/2. So to kind of tie this to recursion, we started at 10. And I'm going to put the 1/2 out front. That's the way we usually like to write a multiplication. Multiply by 1/2 every time. So my equation would, again, start at 10 and multiply by 1/2 every time. So it just tells us how many times are we multiplying by 1/2. And whereas a linear equation with a negative slope would do something like this, an exponential that's multiplying by something that's making it smaller, which of course is anything less than 1, will start off with a pretty steep decline and then level out. Call that exponential decay. Now, things to look for with exponential equations. So let's say we had just a pattern of numbers and we wanted to fit an exponential to it. And of course, you'll notice it's not linear because while we subtract 20, we don't do that again. Okay, so it's got to be an exponential for us right now. The way we figure out that ratio, that multiplier, is to simply take our second term and divide it by the term in front of it. Of course, this is 0.75. So right away, we can say our equation, starting at 80, and then just continuously multiplying by 0.75. Or if you preferred to write 3/4, you certainly could. So again, like this next one, this looks kind of ugly with all these decimals, but very easy to figure out what the ratio is, what we're multiplying by. Simply take the term, second term, and divide it by the one in front of it. And by the way, there's nothing magic about the second term. I could have taken 45 divided by 60. I could have taken 33.75. I would have gotten this no matter what. Same down here. If I'd taken this and divided, it's just maybe easiest, but there's nothing magic about it. So y equals, we started with 12, and we're multiplying by 1.1 every time. So exponential equations are ones that have a constant multiplication. If that pattern or the set is getting bigger, that means we're multiplying by a number that is larger than 1, like this case. If that pattern's getting smaller, the numbers are getting smaller, we're multiplying by a number that is less than 1. If this video helped you, please like and subscribe for more math help.